All right, let's look at the definition of a fractional exponent. Here, if you have a to the 1 over n for any positive integer n greater than 1 and a real number a as the radicand, what that is equivalent to is the nth root of a. So a to the 1 over the n is the nth root of a. Let me give you a bunch of examples. So if we have b to the 1/6, that's equivalent to the 6th root of b. If I have c to the 1/2, that's the same as the square root of c. So this number in the denominator becomes the index of your root. So for example 1, we want to simplify this. We have 49 to the 1/2. That will be the same as the square root of 49, or 7. 64 to the 1/3 will be the same. This will become the index as the cubed root of 64, so that will be 4. Now this one is a bit of a trick. Here, the only thing being taken to the 1/2 is this x. The 2 is a coefficient. So we'll have a -2. X to the 1/2 would be the square root of x. And here, the whole thing's being taken to the 4th power. So this is the 4th root of 81x to the 8th. The 4th root of 81 is 3, because if you take 3 to the 4th power, you get 81. And the 4th root of x to the 8th, if you take 8 and divide it by 4, you're going to get x squared. All right. Finally, let's move on to our last page here. If you have a fractional exponent that has a number in both the numerator and denominator, the number in the numerator of the exponent becomes the power of the radicand, and the number in the denominator becomes the index. So if I had b to the 2/3, that could be the same as b squared, because the number on top is 2, and the number on bottom is 3, so that would be the index. So it would be the cubed root of b squared like this, or we could write it as the cubed root of b, and then the whole thing could be squared. These two things are equivalent, whether you take the 3rd root and this is on the inside, or if the square is on the outside. So looking at, this is kind of handy. Looking at 16 to the 5/4 might intimidate some, but not with us, with our mathematical powers. So what this is equivalent to is 16 to the 5th, that's the power, to the 1/4. Like that. Still looks intimidating, but if we did it the other way, we could totally do it without a calculator. If we write it like this, and then take it to the 5th, the 4th root of 16 is simply 2, and 2 to the 5th is simply 32. So we are strong. Looking at this one, we have a -8 squared, but we want the 3rd root of that. You could probably do this either way. A -8 squared, it sounds terrible to have this negative inside the radical, but it is a cube root, so it doesn't matter. But a negative squared is a positive, so we get the cubed root of 64, which is going to be 4. The other way we could have done it is if we would have done the cubed root first. So the cubed root of -8, and then squaring it, this would give us cubed root of -8 is a -2, and a -2 squared is 4. So either way, we got there. Here we have 81 to the 3/4. Go ahead, do it, and let's check it together. Pause the video, and we'll do it together. Here you'll see we get the 4th root of 81 cubed. I don't want to do it that way, that's too hard. 4th root of 81, if I do it that way, and then I cube it, 4th root of 81 is 3, and 3 cubed is 27. We are brilliant. All right, let's keep rolling. Okay, finally, they might try to trick you with a negative exponent. And as you recall from above, a negative exponent means you just throw this in the denominator. So if I have a negative exponent, this a to the m over n, negative m over n will just become a to the positive m over n in the denominator. Negative exponent means you flip the base, so 1 over a. Looking at that with 16, that'll give us 1 over 16 to the 3/4. That's what it's telling us to do. So that's 1 over the 4th root of 16 cubed. However, I think it would be easier to do it this way. 4th root of 16 cubed, which will leave us with 1 over 2 cubed, because the 4th root of 16 is just a 2, and 2 cubed is 8. So that's 1/8. Here, okay, so this negative is the negative that belongs to the number, and this negative belongs solely to the exponent, so they're not related at all. And what will happen is we will flip this base, so it will become 1 over a negative 8x cubed. Now it'll be to the 2/3. That exponent is still 2/3, but now it is positive in the denominator. So this translates to 1 over a negative 8x with a cubed root, and then squared, x cubed, and then squared. So that will become, so the cubed root of negative 8 is a negative 2. And the cubed root of x cubed is just x. Now that will be squared. So we'll wind up with 1 over. Now it will become a positive 4x squared. Try these last two. Let's see what you get. Pause the video and we'll check. Looking at C, so here's the thing. This negative on my 81 is not inside of parentheses as it was on B. So it just hangs out front all the time. This negative just, it's not part of our radical. So when we put 81 in our denominator, it's still to the 1/4 power, which means the 4th root, which means the 4th root of 81, which is 3, and that negative still out front. So our answer is a negative 1/3. On D, our negative exponent means we move our 27a to the 6th in the denominator, and it becomes a positive 4/3 exponent once it's in the denominator. 4/3 of the exponent means the cubed root, because the denominator tells us the root, the index, of 27a to the 6th to the 4th. If we take this cubed root first, the cubed root of 27 is 3. The cubed root of a to the 6th is 2. So now we have 3a squared to the 4th, and we just take 3 to the 4th, which is 81. And a squared to the 4th, double exponents means we multiply. And we get, finally, 1 over 81a to the 8th. All right. In this area here, we have some summaries of all of the rules we've learned using exponents. And for our final 4 questions here, I'm going to ask you to give them a shot, and then we'll look at them together on the other side. Pause the video and we'll do them together. So in A here, when I'm taking 64 times 64, since that's the same number, we add the exponents. So we're going to add 2/3 plus 1/6. In order to add 2/3 to 1/6, we have to have common denominators. And to have a common denominator, we'd make them both 6, meaning we multiply 3 times 2. So we have to take the 4, or the 2 times 2 to get 4. Now that they have common denominators, we can add 4/6 and 1/6 and get 5/6. So what we have is 64 to the 5/6 power. Now the number in the denominator becomes the index, and the number in the numerator of your exponent becomes the exponent. So the 6th root of 64 is 2, and 2 to the 5th is 32. In part B, since we're dividing the y's, we're going to subtract those exponents, which already have common denominators. So 2/3 minus 1/3, we subtract the numerators and get 1/3. Then we write it as a radical, which would be the 3rd root of y. In part C, when I have double exponents, we multiply them. So 3/8 will be multiplied by 2/1, which would give you 6/4 as an exponent, which reduces to 3/4. Writing that as a radical, this would become the index, and 3 in the numerator becomes the exponent. So you'd have the 4th root of x cubed, or the 4th root of x, taken to the 3rd power. Finally, in D, there are numerous ways you could do it. You could multiply those exponents, or you could write them as a radical right away. If you did that, you get 8 to the 1/3 power, which is the cubed root of 8. We get the cubed root of x cubed and the cubed root of y to the 6th. This simplifies to 2. The cubed root of x cubed is x, and the cubed root of y to the 6th, you divide 6 divided by 3, gives us y squared. Hope that was a meaningful review of exponents for you, and we'll see you in the next video. Thanks for watching.